What changes as Retrieval gets better? Like, what is being held back because this problem is not fully solved?
Delegating more and more to the AIs and like having less and less humans in the loop. We had a customer that saw a clear decrease in the rate of I don't knows of their customer chatbots, which is great because then the thing gets resolved entirely with AI, and there's like not a need for like a human to intervene. So that's been like pretty cool to see that.
Rita, thanks a lot for joining me. Maybe you could start off by talking about what ZeroEntropy does.
Yeah, for sure. The mission of ZeroEntropy is to help humans, and now more and more AIs, find the right information that they need at the right time. When you think about it, a lot of the things that we do, a lot of the productive things that we do is basically just looking for information, processing it, and pushing it back somewhere else. And improving the accuracy and the efficiency of that retrieval system is basically the mission of ZeroEntropy. So we train models and we build retrieval systems that allow to find that information, which can be in a very large knowledge base, nested in a Slack thread, or in a table in a financial PDF. So that's what we do.
Great. I think there's a lot to dig into there in terms of like how exactly all that stuff works. But I mean, how did you end up working on this problem? And what was your background?
Yeah. So my background is more on the math ML side. I studied operations research and machine learning. I've always been interested in training AI models. Initially, it was more computer vision and CNNs. When I met Nicholas, he was basically working on automating medical coding and billing, which was interesting. So we worked on that for a while. And the conclusion of that experiment was that first, our backgrounds are much more aligned with doing infra and training models. And the other conclusion was that the hard thing actually when you're building those AI systems is finding that right context. Feeding all of those codes into the context of an LLM is very difficult or not very efficient. And so that's how we started thinking about connectors, bringing that context into AI agents and LLMs. And we decided to focus on that instead. So that's the story of how we ended up working on this.
But it sounds like perhaps it sounds like there's interesting insights. Maybe when we dig into it, of like coming from a background of actually building models and then switching to this domain where it's not actually building the model, it's feeding things to the model, but then you like circle back on needed to do machine learning again.
Yes.
Okay.
Yeah.
So what is hard about retrieval? Like broadly,
That's a great question. It's hard in many different ways. Looking for information when you have a very, very large knowledge base, that's difficult because initially we had keyword search, so you can like match exact keywords. Of course, that's not enough. Even if you have statistical methods where you can look at the frequency of a term, that's still not great because you need like semantics. Then we had dense embeddings. So dense embeddings are a bit better because you have semantic meaning and you can associate concepts a bit better. But embeddings are still not good enough for a variety of reasons, which we can go into. But we basically need something that's a bit more intelligent than just that. It can also be very personalized. Like searching for information for me could be very different for you. You might have like preferences. So for all of those reasons, it can be very difficult to find information. I don't know about you, but I can never find anything on Slack. It's like the thing I use the most, but for some reason, it's still difficult even on like an everyday tool like Slack to just find what you're looking for. So yeah, it's a very interesting problem to work on and try to improve on.
Yeah. And well, I mean, it's weird because it's firstly, it's like counterintuitive, and the way human memory works is very different. And like the way you prune the tree feels very natural. And so when you try to apply it in this like technical domain, it becomes odd. But then there's this background of like search techniques, pre-prompting that like kind of made sense and like now make more sense. And like, and it's so like, I think as a user, like Slack is just like, what the hell? Like I typed in what I'm looking for. Why can't I find it? But then like, I'm sure as a practitioner, you have intuitions for why it's failing and like what works better.
Yeah, I mean, so what we ended up doing at ZeroEntropy is like we annotate all of our Slack messages. We just like basically do SEO on our own Slack in a way where we just like append keywords so that we can find things more easily. That's the only hack that we found. But yeah, like even embeddings are a bit difficult because when you're embedding a chunk of text, you do it independently from the question that you're going to end up asking. So you're taking like a chunk of text which has a lot of information and you're trying to encode that into a certain number of dimensions, like, I don't know, 4,000 dimensions. And it's really hard to do that in a way that whichever question you're going to ask, when you're going to do that semantic similarity, you're going to have the perfect ordering for any question that you might ask. That's very difficult. Embeddings are not really made for that. Embeddings are great when you're trying to find semantic similarity. You're going to be able to find like the cluster of information, like the cluster of results that might more or less be relevant, but it's going to be like sorted in a completely like random order, and it's not going to be very fine-grained. So there's a lot of things that you can do to improve on that.
Okay, so you start with this corpus of words, right? And you're like chunking it up in a way, and then like the first version is like I just match exactly against the keywords in there, and then some second version is like I add like I try to capture semantic meaning of the words, but then you're like, all right, now we're in this problem of it, like semantics have context and the tokens themselves don't fully capture everything, and especially in longer, bigger corpuses. And now you're at like, I don't know, like the next step is something like expanding semantics via an LLM before you index a thing.
Yeah, I guess you can do things before, like when you're indexing data, you can try to, the way that you're processing it is also going to be important. But something like reranking, which is something that we've focused a lot on, can also help improve the results. So there are a lot of things that you can do outside of just like keyword and then some embeddings to improve those results. But yeah, like adding intelligence on the last step, like you have potential like 200 results, and then you're gonna have a more fine-grained analysis of those results. And then you can even have some form of agent loop, which can do multiple passes, like looking and then reading and then looking again based on the results that you got. So those are like some of the things that you can do to try to improve the accuracy and actually find what you're looking for.
Okay, so there's like this first insight that you can make indexes better for a variety of techniques, inclusive of like, you know, the way you store the vector or the like, and then annotating it, which is kind of similar, like adjacent to that, but still is going in the first pass. And then there's like finally you fundamentally are like, this is not possible in one pass. Like we need something that like goes and finds the candidates that are relevant to what we're looking for, and then some second step, basically.
Yeah, like that's basically what a reranker will do. So as I explained before, when you have embeddings and when you're just indexing data, you're doing that independently from the question that you're going to end up asking. So one thing that you can do is after you have like potential results, you can apply a slightly more expensive technique and ask another model to look at this question and this result and say, okay, is it actually answering my question? So if you have like negative queries or like, I want this, but I don't want that. Well, a smarter model that can look at the question and the result is going to be able to tell you like, is it actually relevant or not? When the embedding is just going to give you like the cluster of all of the things that could potentially match.
And we haven't really even talked about what you do with queries, whether this is like a query language or a natural language that you're matching against the thing in the first place, right? Like that, and that becomes relevant in all these steps. In a retrieval context, are you mostly going against something that looks like a prompt?
Yeah. I mean, depending on how your system is architected, it could be just like literally a user's query, like, oh, this product is not working, like in a customer support chatbot. Like, how do I do this with this product? Usually you'll have like a rewriting step and like get rid of the words that are not really necessary or expand on the query. And then that's what you feed into like your retrieval system.
Yeah. Okay. And then so you've spent a lot of time on Rerankers, right? Like you just concluded that that is like a high leverage point to like make the system much, much better. How did you approach that and think about that? What was like the state of the art?
Yeah. So Rerankers are pretty important because even if your like search system is like sucks pretty much, like it's like very old and you haven't like touched it in a while and you have like billions and billions of vectors, if you add a Reranker step, that's like kind of like a magic way of improving your results, no matter what happens before, because you can retrieve a lot of them.
You can kind of brute force the first part.
Yeah.
Okay.
Yeah. So it can be useful in many, many different use cases. And yeah, so we started looking into Rerankers and we started looking at the state of the art. And clearly there was like a lot of margin to improve on. And so that's how.
And a Reranker is like, it's like constrained to some number of records that it can work over. Like that's what differentiates it from the first pass of search.
Yeah, it works a bit differently in the way that it's going to take both the question and the result inside its context and output a score. Yeah.
All right. Sorry. And you were saying like you started working on Rerankers. Like how did you approach?
Yeah. So it was our first time training Rerankers. So which was a good thing because we had like a brand new approach and vision over how things were done and how they could be done. So we started looking at the state of the art of how Rerankers are being trained.
Okay. And then sorry, because just before we get into them being trained, like a search index is like this index where every like record is an index. A Reranker just goes through everything you give it and is like this one-to-one query output score. Yeah. So it's basically an ML model. The input vector is like the query. Okay. Yeah. All right. So you started approaching training such a model.
Yeah. I mean, there are different types of Rerankers. Like what I'm describing is a pointwise Reranker where it takes like each document separately and outputs a score. But there you could also imagine like a listwise Reranker, which is going to take one question and then a list of results, and it's just going to reorder them. So it's going to take all of the results inside the context. But as you can imagine, you cannot give that many results because it starts to become a bit too much. So yeah, that's how we started thinking about pointwise Rerankers, which are great because you can parallelize the inference pretty much. So they're the most commonly used. So we started thinking about that, but we realized that training a pointwise Reranker is actually pretty difficult. Like if I ask you, what's your favorite city in the world? Or like if I ask you like, how would you rate like San Francisco? And you're gonna give me like one absolute number, like that's pretty hard. Like there's like a lot of variance. Not everyone's gonna give the same answer. If I give you like a list of 100 cities and I ask you, okay, can you reorder them? Like that's also pretty difficult because you need to keep in memory like all of them. But one easy way to compare things is pairwise comparisons. Like if I ask you, do you prefer New York or San Francisco? Like you can tell me which one you prefer. So initially, that's how we started thinking about this, that comparing documents in a pairwise fashion is actually pretty cool and should work pretty well. Like if you ask many LLMs for this specific question of the user, which one of those two things seems to be like most useful, you're more likely to have like a high signal and all of them converging towards, oh, this one is better than that.
And then you have some sort of like ELO, like effective rating system.
Exactly. Yeah. So we started first training pairwise Rerankers. That worked well. And
did that incur like a performance overhead? Because now you have like this.
Yeah, definitely.
I mean, I guess if you're doing ELO, it can be like hierarchical, and so it's not like fully like n squared, but like
so initially we really took the naive method and we just made it more and more complex. But initially the broad idea was we're just going to do pairwise. Like it seems to be working pretty well. And Then the idea was, okay, how do we transform all of those pairwise comparisons into just like one absolute score? Like, how do I transform all of the I prefer this over this into the best city is San Francisco? And that's how we started thinking about Elo, this is exactly what Elo does. And then it's very easy to just create a very big matrix for each question, the Elo of like all of the possible documents. And then we just like fine tune a model to learn these Elos.
And if you know how many documents are going into this given reranking process, you can kind of truncate doing more pairwise comparisons as it becomes clear like what emerges. Okay.
Yeah. And that was like super, super robust. Like learning Elos is making a very tiny model learn Elos.
You literally look at, I mean, is that it? I guess, is that a general algorithmic thing, or is it, I guess I know it mostly in the context of chess, but like, I mean, is it general in computer science?
Yeah, I mean, it's exactly the same principle that we apply here. Is like transforming all of those pairwise comparisons and trying to predict like one absolute Elo score. Yeah.
And so, so you started looking at that and it was working, it started working better, basically, is the next step. Okay.
Yeah, that was like really the breakthrough. Is like, it just worked really, really well. And it generalized also pretty well. And in the end, you end up with a model that does exactly the same thing. It takes a question and a document, but this time it's just basically going to approximate its Elo score compared to the question. Just like if a new player would enter like a chess competition and you try to like predict their Elo score.
Wait, and so that at the other end, once the model is trained, it can actually rate an individual result, or is still like you still end up with a model that's doing pairwise comparisons that you're doing actively during the reranking.
No, that's the cool thing, is that we basically distill the pairwise like super smart model into like a tiny model, but it's just like distillation. Like the big model is just going to teach the small model, and the small model is just going to approximate what the big model would do. So in the end, it's just a pointwise, like the model actually just takes a question, a document, and outputs one single score. But that score is an approximation of what the big pairwise model would predict.
Oh, okay. And this has to be customized per use case, basically?
No, that's the cool thing also, is that we did a lot of like ablation studies, and we found out that like when we added like code, it would improve like biology and finance. So we just like expanded the training set to as many verticals as we could and added a lot of diversity and failure modes. So we had a first version of the model, and then we started seeing a lot of like failure modes. And so we just decided to do like another version to fix them. And now we're like super confident that this like latest model is like really, really strong.
Was that counterintuitive to you? Or did you expect that result? I mean, because I guess it seems like you started this process on this like, oh, this question answer pair is like kind of custom to the context of the question and answer. Mm-hmm. And then you're like, all right, well, if we pair them pairwise, suddenly like this other thing emerges, but then that it like generalizes more doesn't seem intuitive necessarily.
So actually, we didn't do this just for fun. We did it because we looked at how people usually train rerankers, and we saw that there was like a fundamental problem there, which is what prompted us to do something different. The problem is that the way that traditional rerankers are trained is that you have one question, then you have a positive example, and you have a negative example. And you're trying to bring the positive like closer and the negative further away. But the question is, the positive example is just like a human that annotated some form of data set. But like, how do you find the negative example? You could take like a random example from your corpus and just expect that this would be like not relevant. But then like your model's not going to learn anything because it's just too easy. So you want to do like hard negative mining, meaning like you want to find something that seems to be relevant, but actually it's not. And then your model becomes like super, super smart in like complex biology terms. But the problem that we saw is that if you have a really good hard negative miner, the negative example that you find is actually like perfectly fine. It's just that it was never annotated as a positive example. So like your model becomes super confused. Like, wait, you're telling me that this is like wrong, but actually for me, it's like perfectly fine. Like I'm super confused. And so there's like a hard ceiling on like how much you can learn with that method without like looking at like fully annotating like a giant corpus. Does that make sense?
Yeah, I mean it's like the pairwise comparison system is like pseudo like self-supervised or something. Yeah, that's really interesting.
Yeah. So yeah, most rerankers are trained like that, and we were like, okay, let's just do something different to fix it.
Okay, and then so you're like, we care about retrieval. We need to get like, it turns out we have to go deep on rerankers to make sure this works. Like that seems like an insight that's perhaps lost. And then like, how do you package this all together as a product?
Yeah. So basically, our product is a search engine where developers can upload complex PDFs and CSVs and any type of document. And we would do all of that pre-processing, like annotating the data and then indexing it and storing it and doing that retrieval process. And we basically integrate our own models into that pipeline. So for example, this reranker that we trained, there are companies that just want the reranker, so they're just using that. But it's also integrated into that search engine, which makes it super smart and
so and those two things aren't tightly coupled, but like it turns out if you're building both together, they probably work better together.
Yeah, exactly. Yeah. The goal is really to train all of those models that are necessary to make a great search engine, and then integrate them, but also offer them like behind an API if people want to use them.
As you navigated this, I mean, were there major like in things that were like you didn't expect along the way? Like, was the general problem of like getting retrieval better like kind of well understood, or did you actually have to get in front of customers and see like their workloads to understand like what was failing and what was working and where to spend time?
I think what's interesting is that now the search systems are used by like AIs, which kind of like changes things a little bit. The use cases are like very different from like what traditional search does. One example is we're working with this memory layer company where basically they're storing your memories and then it makes like the AI more personalized for you. And they had this problem where basically they're not just looking for purely relevant information. They're trying to find helpful context. So search is not just question answer anymore. It's also, sometimes it's like somewhat related. It's adjacent to your question, but it's like helpful context for the AI. Like in order to make like a helpful assistant that can do a lot of things, it's not just like, for example, like what's your favorite city? It could be like, oh, I really like biking. Like that's not answering the question, but it's like helpful context. Like if an AI knew that about you, it would make the answer better and it would make the output better. So that's like a fundamental difference between like how search is evolving and a traditional system, like any reranker or any system would score that I like biking like super low. Like it's like not relevant, but it kind of is. Like it's kind of helpful.
Well, kind of calls back to the Slack example. What I think I find personally frustrating about Slack is that I'm not, unlike like a web search where I have a general idea and I want a bunch of random relevant things. Slack, I often have thought, I'm thinking of something very specific. Like I remember this thing happening and I don't remember exactly how it was described at the time, but I want to find that piece of conversation from N days ago. And so like all my personal context around like what's going on in my head is very relevant to like that sort of search.
Exactly. Yeah, that's like a real difference as well. Yeah, it's very different from, exactly what you described from internet search where there could be like a lot of relevant information and you just want some like diversity in it.
Slack is very binary.
Yeah, it's
like
very
it finds
binary.
The right thing or it doesn't.
But the level of frustration also like significantly goes up when you know what could be done, but it's just like not working. And I think it's also dangerous when you're trying to automate some form of task with an agent, because like if the information is there but is not used, like the output and like the set of actions that are going to follow are going to like diverge completely.
And then, I mean, it reminds me of other like problems with agents too and retrieval, because it's like there's often like in Slack and like in the rest of my information flow, there's like a temporal aspect where like there's the wrong answer and the right answer in the data set.
Yeah.
And they're both equally like relevant on some like abstract level. Yeah. But one is still wrong. Like one is still like I could have changed my opinion about something. And both could be in there.
Yeah.
Right. But I want the current, and currentness is part of correctness.
Yeah. Like that. Yeah, totally. One thing that we added to the latest model is you can basically add like some form of like business or general context, which is going to like stir the model in like a direction or another. Like you could say to the reranker, like, I'm Brett, and like I usually ask about this, and this is where I work, this is what I do. And it might like change how results get re-ranked a little bit. And that's been like pretty helpful for like some use cases. Yeah.
And do you it feels like for most of the use cases, like the path you're on is like just keep improving the re-ranker and we'll get closer and closer to like getting it right? Or like do you feel like there's missing pieces that you still need to do R&D around?
When we released ZRank 1, it was our first model, so it was interesting to see the failure modes. And once we were deployed, like in production, we started seeing some like failure modes, and that's what ZRank 2 is fixing. I don't think we're gonna make a lot of improvements in like the near future because we've gained like a lot of confidence in this latest model. Like it even tops like independent benchmarks, and we know it works really well. And maybe like we'll wait until we accumulate like more failure modes before we fix problems if they exist. But there are other parts of like this retrieval pipeline that are still broken that we're now going to start addressing.
Do you think that does it feel like a moving target as you're shifting from like people trying to do prompting to like, I don't know, function calls coming out of LLM? Like is the shape of like what you're trying to solve for and like what right is in retrieval changing?
I think accuracy and latency are always like what we're trying to solve for. I guess it's more like the definition of accuracy that's like changing a little bit, but that's something that we
sometimes it feels like it feels like a measure of clairvoyance. Like it's like like the system. I want the system to know what I want in my head, right?
Yeah. But I think that's been like the major difference that we've noticed. But now it seems pretty clear what those agents need, and like the objective functions is a lot clearer now. Yeah,
that makes sense. Are you like what like I guess like internally what's going on? Have you leaned heavily into? Are you using a lot of AI writing your code? Is that like a per person decision on the team? Is it like a team wide top down imperative to be using these types of systems, or like how useful is it these days?
Very useful, but in different types of areas. So for everything like full stack, like dashboard, like building dashboards and front ends and things like that, like it's great. Like we use AI a lot. AI tools are also great for like data analysis and data analysis and data science, which we had to do a lot of, obviously, like running evals and trying to like understand the data and find patterns in the data. That's been pretty helpful. Synthetic data generation is difficult, but is possible. And we've used that a little bit. But in terms of like writing like training code or like infrastructure code, like usually it's not even like that many lines of code. And it's just not worth it. So we haven't been like using AI too much there, but definitely super helpful for all of those other tasks of like, data analysis and full stack type of work, if that makes sense.
Yeah, it does. I mean, it's like things where the output is like well represented in the models, and you just tell it to go do it. But there's a lot of engineering tasks where like the hard part is like pruning what not to do, and the models start to go do something random, and then
super verbose. Too many lines of code, like way too many. But for like spaghetti code of like one-time demo or like we built this like random like NeurIPS like tool where you could like ask questions about the latest NeurIPS papers. Like, yeah, it's like great for stuff like that. Once you already have like the core components. But yeah, that's been our experience. Definitely for like data analysis and like doing graphs and like understanding data, like you can have an idea, oh, I want to look at like specifically this data set, like how is this structured and like what does that look like and what's the repartition of this and that. Like it's great for stuff like that. And you can get from like, oh, I want to learn more about this to like you have a nice graph with everything that you need and you can like gain insights a lot faster. So it definitely improved our productivity like a lot. Like I don't think we would have been able to like train these models this fast with like such like a small team without like AI tools for sure.
Do you build much tooling, like internal tooling around these things, or are you just kind of waiting for the models to get better? You know, how do you balance like actually like, it seems like you can get the current generation to be more useful if you spend a lot of time on it, or you can kind of wait for the next generation of code tooling. And like, how to, like, is that something that you debate internally or think about?
I guess what we debate is like which model is good for what, and like try to do some like pattern matching and understand, yeah, each model has kind of like a personality and like pros and cons. So understanding that as soon as they come out is pretty useful because then you know how to leverage them. And yeah, like we've been like building a lot of like, for example, like synthetic data generation pipelines. And for that, you need to like understand the models like pretty well and how they're going to react and how to prompt them. It's like a lot of prompting. So yeah, we just like use the best models, but also we need to like gain confidence in like their output and like the types of failure modes that they have. Like, for example, this model, like there's like X percentage of the time you're going to ask it to like output a number between 0 and 1 and like it's going to output like 3 million, like randomly, like 2% of the time or something like that. And like having intuition, like, yeah, this one does this, like it's just not listening to me. This one is like too tiny to understand like this set of instructions. Like that's pretty helpful because then like you can like use them where they're most helpful.
That makes sense. Because when you're evaluating it for your own productivity, like variance is a big deal. Independent, like as a like not just like the high, like what can it do in its best case.
Yeah.
Do you think, I mean, as you see like what your customers are trying to do and you think about like how much better you can make your product, like this might be an odd question, but like do you think like what changes as Retrieval gets better? Like what is being held back in technology or in software right now because this problem is not fully solved?
I guess it's like delegating more and more to the AIs and like having less and less humans in the loop. If you can definitely trust the retrieval, the tool use of like these systems, then they can just do things on their own. One like way that we've seen this, for example, in the customer support space, where we had a customer that saw a clear decrease in the rate of I don't knows of their customer chatbots, which is great because then the thing gets resolved entirely with AI. And there's like not a need for like a human to intervene. So that's been like pretty cool to see that, like, yeah, like just you swap the model and then you see like, I don't know, just like going down and you can actually find the thing like you do know now.
Yeah.
Yeah.
And there's like these, and for a lot of these products, there's this, the threshold for you, the threshold of accuracy for actual utility is higher. And so you could see like things that were not possible just because they were like just under, like consistency was just under what it needed to be, or now it can be like deployed in the world.
Yeah.
That's interesting. So what should we look forward to from ZeroEntropy?
Yeah, I mean, we're doing a lot of cool research on more models. So Rerankers, we feel like we're pretty confident, and it's gonna take a while for other teams to like catch up. But you can expect more cool models and research and brand new ways of training those models in a way that's like a step function better. And this whole pipeline of like retrieving information behind like PDFs and UIs and and just gathering all of that context and giving it to the agents. So yeah, we're pretty excited.
Awesome. That is quite exciting. So this has been great. I feel like I learned a lot. So thank you.
Oh, thanks for inviting me.